All right, so I'm back. Hopefully everything's working. You can hear me. I am going to be going over the ballistic pendulum question. So this is my favorite question to put on the energy and momentum test in grade 12 physics. My physics students have a test tomorrow, so I thought I'd go over this question. If you want to go over more questions or multiple choice questions, things like that, you can watch one of my previous live sessions on my channel, so go check it out. But I'm going to dedicate this live to the ballistic pendulum. If you have any questions, let me know in the chat. All right, so let's start. Here we have a 38-gram bullet is fired with a speed of 180 meters per second into a 5-kilogram sandbag pendulum 1 meter long that is free to swing. To what maximum angle will the pendulum make with the vertical? So let's look at what this looks like. So we have some sort of ballistics, and we are going to be firing a bullet at a speed of 180 meters per second. So the bullet's mass, we will change to kilograms, so 0.038 grams. Okay. And then we are going to hit a sandbag. So we're going to hit this 5-kilogram sandbag. So 5 kilogram. And it is a pendulum that is going to swing up to some maximum angle with the vertical that we will just label as theta. Kind of writing over the question here, but a big drawing is a good one. All right, so we need to figure out what theta is. I like this question because we have to look at both momentum conservation and energy conservation. So it's a 2 or even 3-step problem. The first step is a collision. So the bullet is going to collide with the sandbag and become embedded in it. So that is a completely inelastic collision where both objects stick together and end up having the same velocity afterwards. So we're going to start by figuring out what that sort of v prime velocity is for both of them together. So momentum conservation. So P total equals P total prime. So initially the sandbag doesn't have any momentum, so it's just a bullet. So I'm going to call this object 1 and this object 2. So we just have M1V1. Okay, and that is going to equal, after they're stuck together and moving together, so we have both masses, M1 plus M2, time their combined or moving together, their velocity after the collision, v prime. So there you go. We can solve for v prime if we divide by the sum of the masses. So we get v prime equals, so M1, we have 0.038 grams, kilograms, because I converted it, kilograms, times its velocity, 180 meters per second, all divided by the sum of those masses. So we have 5 kilograms plus that 0.038. So we have 5.038 kilograms. All right, so we can take out calculators. 0.038 times 180 over 5.038. So we get 1.358. I have a couple extra significant digits because we're only partway through the problem. 5.8 meters per second. Okay, so the next part, we need to figure out how high this is going to go. So to what maximum height will it reach? This is an energy conservation problem. So we are starting here at a height that we'll label as our base. So that'll be a height of 0, and this is what we're looking for. What is the height here? So we're going from, we have kinetic energy up to gravitational energy. So our energy conservation, ET, equals ET prime. We go from kinetic to gravitational. Kinetic is 1/2 mv squared. And gravitational is mgh prime. Okay, our masses will cancel because they're both the combined masses of our bullet and our sandbag. This v here is the v that we calculated here. It's the velocity they're moving together right at this point, right after the collision. So we're trying to solve for h. So if we rearrange for h prime by dividing by g, we get v squared over 2g. So that equals, we got 1.358 meters per second squared, all over 2 times 9.81 meters per second squared. So that's going to give us our height. Back to our calculators. 1.358. 2 times 9.81. Okay. So we got 0.094 meters. All right, or 9.4 centimeters. All right, now we still need to figure out what theta is right here. So we know that the pendulum length is 1 meter long. So this length is going to be 1 meter, but also this length is 1 meter because the pendulum doesn't change its length during the swing. So if I sort of draw a horizontal here, we just figured out what this is. That's h. Okay, it's 0.094 meters. So since we know what that is, we can figure out what this portion is. It'll be 1 meter minus that 0.094 meters. Now, since if we look at this right angle triangle here, knowing adjacent and hypotenuse, we can use cosine. Where am I going to do this? Over here. So the cosine, maybe a little lower so you can see it. Here we go. Cosine of theta is adjacent, which is 1 minus 0.094, and it's too late for me to be thinking about this. 0.094. So we've got 0.906 meters. The meters are just going to cancel over 1. So take our inverse and we can figure out the angle. So inverse of cos 0.906. There we go. 25 degrees. So it's going to go up to an angle with the vertical of 25 degrees. Now sometimes I can ask this problem in reverse, where I give you the angle and I ask you to go the opposite direction and figure out what the initial velocity of the bullet is. So that's another possibility I can do with this question. I can give you theta and you'd have to do everything I did in reverse to figure out what that velocity would be. Okay. Any questions with that? It's a short live. I know it was late, but I wanted to give one question. Okay. If you wanted to go over some more, make sure you go watch my previous live on energy and momentum. And my students, I will see you tomorrow. Good luck. I hope this time you could hear me.